Today I'm going to discuss on standardized rate or adjusted rate. Standardized rate and adjusted rate is an important topic in epidemiology and biostatistics. This refers to a statistical measure that adjusts the rate within a population. Purpose is to remove the difference between two comparing populations, which results from a confounding variable. For example, a common confounding variable can be age distribution. There are two methods to calculate age-adjusted rate. These are direct method and indirect method. To discuss this topic today, I have copy and pasted the following tables from an article. The reference has been given here. The population under study are population A and B, and also we need to have a population which is standard population or reference population. I call this population as population C. In this article, the author didn't mentioned about reference population, but didn't give any name like population C. For facilitate this discussion, I thought populations indicating population C would be much more helpful. The table 1 has been taken from the article. In this table, we see there are few columns and the total table is divided into data from the population A and population B. These are our study population and we would like to compare their mortality rate among various subgroups. The subgroups are divided in by age factor, age variable. Age-specific groups are, for example, 0 to 24, 25 to 49, 50 to 74, 75 and above. This is our age distribution for all three population. There is one more population, that is population C. We don't have any table for population C, but we are going to use some data from the population C, calculate our age adjusted death rate. So the first column is the age subgroup based on the age, and then second column is the mid-year population. These are the number of people per subgroup or each subgroup. And deaths. These are number of deaths per subgroup. Number of deaths per subgroup. And age-specific death rate, we have to calculate this from the first and second column for each subgroup. To do that, the formula or the method of calculation is we will take the number of people from each subgroup. For example, I'm showing one that is age group 0 to 24. The total number of death is 35. So this is the numerator, and denominator would be the total number of people in that group, and then we will multiply with 1000 to get the age-specific death rate per 1000. This will give us the number of 1.94. That's how they found this, determine this age-specific death rate per subgroup. Similar method we have applied to the population B, and we get the age-specific death rate per 1000 people for each subgroup. These numbers we are going to apply in the second table. We also calculated crude death rate per thousand. To do that, total number of deaths for this population A, and then total number of people for population A, and we get the crude death rate. You all know it's total number of death per population into 1,000. If you want to calculate by 1,000, that will give us the crude death rate. Same method has been applied for population B, and we have the crude death rate 24.57. So by seeing the crude death rate, it's as we can assume that it shows that the crude death rate is higher in population B than the population A. Next table, let's go to the next table. The table 2, we use the age-specific data that we calculated for each population A and population B. But here we are going to calculate the expected death. To calculate the expected death, we have to use this column, that is age-specific death rate, but we also want to use the standard population from the standard population population C for each subgroup. The number of people per subgroup in population C is this number. So for 0 to 24 is 11,000, and this population is a common for that we are going to use for both population A and B to standardize. The formula for the expected death rate is very simple. We will multiply age-specific death rate from each population, each subgroup, and then you take age-specific death rate per subgroup, and then multiply with the number of people in particular subgroup. This was taken from the population C, and then we multiply, and we have to divide by 1,000 because this rate is counted as per 1,000, the age-specific death rate. So from there, we will get the expected death, which is 21.37 for the group of 0 to 24. Similarly, we count all this expected death, and then finally we add up all this as expected death to get the total expected death total. This number we are going to use to calculate the age-adjusted death rate. The age-adjusted death rate can be counted from taking this expected death rate total divided by total number of the people in this is the population in population C, number of people in population C. So expected death divided by number of people in the standard population into 1,000. That will give us the expected age-adjusted death rate. By calculating this age-adjusted death rate, we can see an interesting fact is population A has more death than the population B. So that's how it is important. That's why it is important to calculate the age-adjusted death rate to get the true result. The population A has 23.3 per 1,000 people. That is the age-adjusted death rate in comparison to population B, which has 22.7 per 1,000 population. In next video, I'm going to discuss about indirect method. This was direct method, and indirect method I'm going to discuss in the part 2 video. Thank you.